Section 6.3, we get to deal with vectors. And I'm going to look at 4 problems today for your homework help. First one is going to ask you to find a unit vector that's going the same direction as the given vector I minus 2j, which remember is linear combination instead of component form, which we tend to use more frequently. Second one's going to ask you to find the vector v with the given magnitude, so they tell us the magnitude of that vector is 6, and going in the same direction as vector u. Third problem is going to ask us to find the component form of vector v, given its magnitude, for this one 5/2, and the angle it makes with the positive x-axis, which they're telling us is 45 degrees. And hopefully what you'll recognize, and I'll try to point it out if I can, that problem number 2 that we just looked at and this problem are virtually identical. And I'll try to show you that when we get there. And then the last one is a story problem. It's the plane problem. Plane is flying at a bearing of north 17 degrees west at a ground speed of 315 miles an hour. Ground speed means the actual plane speed if the wind didn't exist. There is a wind speed of 62 miles per hour blowing with the bearing of south 82 degrees east, and it wants you to find the direction and airspeed of the plane basically affected by the wind. So when you see airspeed, that means the speed of the plane with the wind affecting it. Alright, so back to the first one. Find a unit vector, same direction as the vector w is equal to I minus 2j, which of course if you prefer the component form is just that in component form. So I don't need to draw a picture of this, but to show you what we're looking at, if I were graphing that point, it would be 1, negative 2 would be right about here. This is vector w. Now it says to find the unit vector, which think unit circle, that means it's 1 unit long. So if I drew the little unit circle here, it wants me to find that vector here. So right now the vector is blank units long. We don't necessarily need to figure it out right this second. I want to know how can I shrink that down so it's only 1 unit long. So it's just like dealing with the unit circle. If you remember some of the unit circle problems, what you want to do is to basically, you're going to end up finding the magnitude of this vector and then dividing both of the x and y value of the components by that magnitude. So really you're going to make yourself a right triangle. This is 1, this is negative 2, and then I'm going to do a squared plus b squared equals c squared, which is exactly what you do to find the magnitude. So if I said I wanted to find the magnitude of vector w, I would do the square root of a squared, which is the x component, plus b squared, which is the y component. And that's the exact same thing I'm doing over here if I do a squared, b squared, c squared. So it's the exact same idea. This is how we showed it in class, and this is what I want you to do. But if you think of it this way, it's fine. It's the same steps. So I take 1 squared, I take negative 2 squared, and I know that the magnitude of vector w is actually the square root of 5. That's how long it is. And what I'm supposed to do now is take both of these components and divide it by square root of 5. And so the unit vector would be 1 divided by the square root of 5, comma, negative 2 divided by the square root of 5. Now don't leave it like that. You never want to leave something like this that's got a radical in the denominator. You want to rationalize it. Your final answer should be square root of 5 over 5, comma, negative 2 square roots of 5 over 5. And this vector, if I were to draw it out, would be that little vector right there. It's going the same direction. So if you remember how we found the direction angle, which we'll get to, where you would take the tangent inverse of y divided by x, or b divided by a, you do that for that or that, you're going to get the exact same angle, meaning it's traveling the same direction. And if you found the a squared plus b squared equals c squared, found the magnitude of this, it would actually give you 1. All right, so that's finding the unit vector of any vector going a specific direction. This one now wants us to find the vector. Doesn't say whether it wants component form or linear combination, so we'll probably just give a linear component form. Find the vector v that has a length of 6 that's going in that direction. So what I'm going to do is figure out what the angle is here. They gave me numbers that are really easy to work with on the unit circle. They're the same. So if you think about the 45-degree angles, I could easily figure out what that is. Or If I want to switch a vector into component form, I need two things. I need the magnitude, which they gave me, and I need to know the angle that it's traveling. So I could easily, if I didn't recognize that that was a 45-degree reference angle, I could do the tangent inverse of y divided by x, and that would tell me that this is going to be negative 45 degrees. Now you need to be very, very careful when you're doing this. Anytime you use tangent inverse, you may not actually be getting the right answer. Take a look at that. Think of the point. If you were to graph that, negative 3, positive 3 is over here in the second quadrant. So when you see this answer of negative 45, which is right there, that is not correct. It's giving you the reference angle. The calculator doesn't know what angle you're actually dealing with because it's restricted. So you need to understand that this is actually 135 degrees. So theta is 135 degrees. Once you know the length of the vector that you want and the angle that it's traveling along, you can switch this into component form. And this is the exact same idea that we're going to use when we do that plane problem on the back that you saw. So what we do is we do this. You take the magnitude and you multiply it by the cosine of theta and the sine of theta. And that will change it into component form. Think about what sine and cosine does. I take the sine or cosine of any angle, that just gives me an x and a y value on the unit circle. Multiplying it by whatever number will stretch it out so that it has a length of that. So I'm going to plug all my information in. I'm going to have 6 times the cosine of 135 times the sine of 135. And those are ones that we should recognize on the unit circle. And so, if I remember that, I know that that's negative square root of 2 over 2. So 6 times negative square root of 2 over 2, comma, that would be a positive square root of 2 over 2. Simplifying, I would end up with negative 3 square roots of 2, comma, positive 3 square roots of 2. And this vector in component form will be the vector that has a length of 6, meaning if I do a squared, b squared, c squared, it'll eventually give me 6. And it's going to give me an angle of 135 degrees if I do the tangent inverse. All right, now notice what we did here. Notice how I took that and I switched it into an angle. Now watch the next problem. It gives us the length and it gives us the angle already. So when you look at this problem, the way it's worded, and then flip back and look at the last one the way it's worded, they're giving us slightly different information, but almost exact same thing. This is going to help me figure out what the angle was. Here they just tell me what the angle is. So this one's actually nice, quick, and easy. I just take the length, or the magnitude, and multiply it by the cosine of the angle, which they told me was 45, and the sine of the angle. And again, this idea is important because this is what I want to use when I do my plane problem or the story problem down below. All right, hopefully I recognize those again. That means this could be on a non-calculator part because I'm supposed to know what the cosine and sine of 45 degrees is. I know they're both positive square root of 2 over 2. And now if I simplify, I would get 5 square roots of 2 over 4, comma, 5 square roots of 2 over 4. Simplify if possible. There is my answer in component form. If they want a linear combination, it would be just that I plus that j. All right, now taking that idea and applying it to the plane problem. All right, it deals with being able to switch your information into a component form vector and vector addition. It's kind of combining both of them. So we did one in the notes. You can try to follow along with that and then look at this and see if that will help you. But if I draw myself a picture, it says that the plane is flying at a bearing of north 17 degrees to the west. So there is my plane, and this is 17 degrees. And then it says there's a wind blowing 62 miles an hour and it's going south. So from the end of this plane, wherever you stop there, if you went south 82 degrees to the west, this is representing the wind vector. Not a very good picture, but there's the wind vector, and this is 82 degrees. And so what is it that I'm looking for? I'm looking for where I originally started my picture to where I ended it. I'm looking for that vector. This is what the vector addition is asking me to do. So it's take that vector plus that vector. It's going to give me my answer vector, if you will. Well, I don't have any vectors to work with, so that's my job. Come up with these vectors with that story problem, that information. So, what do I want? Of course, I want to know what the magnitude is, which is referring to speed per 1 mile an hour. And I want to know what the angle is. Be very careful with this. It's not 17 degrees. When I drew that picture, I'll draw another one. It was north 17 degrees to the west. Well, remember when you measure an angle, you're always supposed to measure from the positive x-axis. So 17 is not what I want. I actually want 90 plus 17, or 107. So the plane's vector is going to be 315, there's the magnitude, times the cosine and sine of 107 degrees. If you use 17 degrees, think about that. 17 degrees would be right here. That's going to give you a positive x value, positive y value. If you look at this plane, you should have a negative x value, positive y value. So it's going to give you the wrong information. So just be very careful. That's a common mistake, is that angle. All right, and then of course I'm going to do the same thing with the wind. I'm going to look at its information, and I can see the speed of it is 62 miles an hour, so it's 62 times, remember, be careful with that. If I drew that picture out, it's south 82 degrees to the east. This is 82 degrees, so think about what is that, or you can also use the negative angle if you want to. So if this is 90 and that's 82, I know this is 8 degrees. So it's your choice. You can either say the cosine of negative 8 degrees, or you can say 352 degrees. Either way, it'll come out the same, because we know that those are coterminal. All right, and now all I have to do, same thing I did up here, figure out what it is. I'm not going to use radical numbers. I'm probably going to have decimals, because we don't know those numbers off the unit circle like we do 45s. So I'm going to use my calculator, make sure I'm in degree mode, and I'm simply going to type in cosine of 107, multiply that by 315, and there's the x value. So on my plane vector, I have negative 92 point. I would suggest going out 4 decimal places for this. The further you go out, the little more accurate you'll be. You want to put them all down, you can. There's the x value. Now figure out what the sine is and distribute the 315. So sine 107 multiplied by 315 should give me positive 301.2359. I guess that's going to be 60 when I round it. So there is my plane vector. That x and y coordinate or component is what's giving me that vector. Now when I do the wind vector, it'll give me this one. So now I figure out the wind vector, same thing, type in the cosine of 352, or negative 8 if you use that. Multiply that number by 62, the magnitude, and your x component is 61.3966. Sine of 352 times 62 is going to end up giving you negative 8.6287. And now there's an x and a y value, or components of that vector. And now remember, what are we doing? We're taking this vector plus that vector to get that vector. So what do? I'm going to take these two vectors and I'm going to add them together. I'm taking the plane plus the wind, and what that's going to do is that's going to give me the plane with the wind affecting it. And it's going to give me a vector. So it makes sense if I add these two numbers together, it's going to be negative. And look at my picture, that would make sense. I should have a negative x value. I am going to the left. So adding these two numbers together, negative 92.0971 plus 61.3966 is going to give me negative 30.7005. That's my x component. Or in other words, that's how far I'm traveling to the left. Add the y values together, 301.2360 minus 8.6287 gives me a positive 292.6073. And now if you ask yourself x and y value, does that make sense with that picture? Moving a little bit to the left, going up quite a bit? Yeah, I mean, my picture is not 100% accurate, but yes, that does look like that makes sense. That is not your final answer. That just gives you the vector. Now think about what they're asking you for. They want two things. They want to know what's the direction, which we'll do that second, and then what's the airspeed. In other words, what's the magnitude. Now that I've got this vector in component form, all I need to do is find the magnitude of it, and that'll give me the speed. So the speed is equal to, I'm not going to write the whole thing out, it's the square root of a squared plus b squared. So let's go ahead and type this in. It's 30.7005 squared plus 292.6073 squared. And that gave me the square root of 86,561.55271. And of course I'm going to take the square root of that, so square root of that number is 294.2, and this is miles per hour. This is actually my speed. Ask yourself if that makes sense. You're traveling 315 miles an hour that direction. The wind is blowing that direction. It makes sense that it's going to slow you down. If it were blowing, say, that direction, well, it's actually going with you. It should speed you up, or that direction, it should speed you up. So it does make sense. If you had an answer of 2,000 miles an hour, that probably doesn't make sense. Now to find the direction, if I go back to this picture, hopefully you can actually see it. What I want to do is I want to find the angle. What angle is this thing traveling along? So what I could do is figure out what is the angle. And then remember, to find the angle, the theta, all you have to do is type in the tangent inverse of this. So it's the tangent inverse of b divided by a. I'm kind of running out of space here, so I won't write it down. I'll just go ahead and type it out. So second tangent inverse of 60.73, tangent inverse of, that's 292.6073 divided by negative 30.7005. Make sure that you do put the negative in there because only one of them is negative. Hit enter. Now remember, it's negative 84 degrees according to your picture. That is this. Negative x, positive y. I know that that's actually not right. I need to add 180 degrees to it. And it's actually 95.98, or let's just round that to 96 degrees. So that is this angle here. Well, to give my answer in terms of a bearing, I don't want this 90, I just want that little 6. I'm going north, and then I'm going 6 degrees to the west. So my answer would be north, 6 degrees west. And there's my actual answer. Kind of a lot going on. It's a great problem to look at. We looked at one in the notes. You'll have a couple of them in the homework like this. But a very nice problem to kind of run through and try to figure out. If you have questions, let me know.